If I handed you a classic 3.5-inch floppy disk from the 90s, you would struggle to save just one high-quality photo on it. It holds a maximum of only 1.4 megabytes. But its cousin, the Iomega Zip disk, looks almost identical, just slightly thicker. Yet it can hold up to 750 megabytes. That is over 500 times more data. How did engineers pull off this magic trick? It wasn't one giant invention, it was a series of brilliant, tiny tweaks to the physics and geometry of the drive. Let us break down exactly how small changes led to these massive results. Tweak number 1. The read and write heads. On a standard floppy drive, the head that reads and writes data is relatively bulky. Imagine trying to draw detailed lines using a thick permanent marker. You can only fit so many lines on a single page. Now, the zip drive shrunk its read and write head down to about 1/10 the size. It is closer to a hard drive head. Imagine switching from that thick marker to a fine-tipped technical pen. Because the head is smaller, it can read and write on incredibly narrow pads. This allowed the zip drive to pack 2,118 tracks per inch onto the disk, compared to the floppy drive's paltry 135 tracks per inch. More tracks squeezed into the same physical space means exponentially more storage, plain and simple. Tweak number 2. The magnetic coating, or as engineers call it, the cookie. Floppy disks used basic, cheap magnetic particles. But the zip drive borrowed high-quality particles developed for S-VHS videotapes. These particles have a higher energy level, meaning they are harder to magnetize. Why is that a good thing? Because it takes a stronger, more focused magnetic field to change their state. As a result, the magnetic field stays perfectly contained. It does not bleed over to the neighboring bits. Think of it like writing with a fountain pen on cheap paper versus a ballpoint on premium cardstock. The zip drive's advanced coating allows for much smaller, sharper dots, zeros and ones, so you can pack vastly more bits. Tweak number 3. How the drive organizes the space, known as recording zones. A conventional floppy disk uses radial sectoring. Imagine slicing a pizza into equal slices. The outer edge is longer, but the floppy disk forces the same number of sectors on outer tracks as inner tracks. This means the outer tracks have huge gaps of empty, wasted space. It is a terrible use of the recording surface. The zip drive uses zone recording. Instead of equal slices, the drive keeps the data density constant across the entire disk. As the heads move toward the outer edge, the disk automatically packs in more sectors. This ensures zero waste. So, how did the zip drive jump from 1.4 megabytes to a whopping 750 megabytes? It was death by 1,000 tiny cuts in the best way possible. Each tweak multiplied the effects of the others. This resulted in a 500-fold increase in capacity. Microscopic changes in hardware design can lead to astronomical leaps in performance. Thanks for watching. If you enjoyed this deep dive, make sure to like and subscribe for more tech stories demystified.